Good everyone, my name is Graphics. If you look at the front of the screen, you will see a table, and the question that back up this table says a fluid system contains in a piston cylinder machine passes through a complete cycle of four processes. The sum of all the heat transferred during the cycle is negative 220 kilojoule. The system completes 120 cycles per minute. Complete the following table showing the method for each item and compute the net ratio of work output, right? So this is what we have here. Now, if you look closely, we need to understand the parameters that are given here. Now, we are given a state. I will know the state is the overall condition of a system at a given point in time, right? That means 1 is state 1, 2 is state 2, 3 is state 3, and 4 is state 4. What is a process? It is when the system moves from one state to another, right? So the system moves from state 1 to 2, that's what we call it process 1 to 2. The system moves from state 2 to 3, we call it process 2 to 3. The system moves from state 3 to 4, that is process 3 to 4, and 4 to 1, that is what process 4 to 1, right? Which we know that a cycle is when the system undergoes series of what? Of processes such that the initial point is equivalent is to the what? To the final point, right? So now, if you look at now, we have another item here, which is Q. The Q here is used to denote the heat, right? And we know heat is a form of energy that flows as a rate of what? Temperature difference. So between process 1 to 2, the heat is 0. So there's no heat input or heat output at this particular point, right? And if you look at process 2 to 3, the heat here is 22,500. So since it's positive, meaning that what is an heat input, the heat is gained. Now, if you look at process 3 to 4, the heat here is heat output because it is negative. So we're having negative 2,250. And for process 4 to 1, we are told to look for the heat. That we have dash there. Now, the next parameter here is the W, and the W is the work, and is in kilojoule per minute. Both of them, they are 1 kilojoule per minute. So the work at process 1 to 2 is 3,120, and the work at process 2 to 3 is 0, so there's no work done here. And the work at process 3 to 4 is not given, so we are going to look for it. That's why you see it dashed here. The work at process 4 to 1 is also not given. Now we'll go to the next parameter here, which is the internal energy, right? We use U to denote the internal energy, right? So the internal energy is dependent on temperature. If the temperature of a body is high, the internal energy will be high. If the temperature of a body is low, the internal energy will be low, right? And this causes the intensity of what? Molecular activities in the body. So that is by the way. So now you can still click on this video here to explain all these terminologies I just brushed through now. Now we'll start working. So for you to look for the net ratio of work output, we need to fill in the table, fill in the gap in the table. So we'll start by the first one here, which is the heat, right? The first one here, which is what? Which is the heat. So at process, we recall, right? We know that the total heat input is equals to the internal energy plus the work done. The total heat input is what? The total internal energy plus the total work done. I will term that my question 1. So taking that is just saying about the first law of thermodynamic, which is in line with the law of conservation of what? Of energy. That says that the total energy that you put into a system is equals to the total energy that is stored in the system plus what? The work done by the system. That is what this statement is telling us. So I'll turn that my question 1. Now, if I look from process 1 to 2, right? You discover that Q1 to 2 means the heat at process 1 to 2 is 0. Just like you can see, it is not given. It is 0, there's no heat input. It is given, but it is 0, no heat input, right? And that is, it is adiabatic there, no heat input. And the work done during that process 1 to 2, right, is given as what? 3,120 kilojoule per minute. We're talking about process 1 to 2, so we're working on that row. Now, the internal energy U1 to 2 is unknown. That's why you're seeing dash there. So what we're going to do is the recall will substitute in our value into equation 1. So the heat, total heat input there is given as Q12, and that is 0, equals to the total internal energy, right, is not given, and we'll call it U12, plus the total work done here is given as 3,120. So if I make my U12 the solid of the formula, my 3,120 will go to the left hand side, and that will make it become negative. So my U12 will now give us negative 3,120 kilojoule per minute. So I'm going to write it in this table here. So that's what I've placed there. Is that taken? Now the same thing applies to going to process 2 to 3, right? So when the system moves from state 2 to 3, what will happen? So if you look at state 2 to 3, the heat transferred between state 2 to 3 is what? 22,500 kilojoule per minute. Is that taken? That is, you can see on the table. And the work done from state 2 to 3, which is process 2 to 3, is 0. So there's no work done there. Then the internal energy in this system here from process 2 to 3 is unknown. That's why you're seeing dash there, right? So what I will do is I am going to also substitute into equation 1, right? Recall that the Q is equal to du plus the W. That's my equation 1 here. So what I'm going to do here is the Q here is given to be 22,500 equals to the U here, that is U2 to 3, is given as is not unknown, and the W2 to 3, that is the work done between state 2 to 3, is 0. So if you make the internal energy here, we'll be having the internal energy from state 2 to 3 will give us 22,500 kilojoule per minute, right? So I'm going to put it in the table here so we can see it. Now we'll move to the next one. From process 3 to 4, that is when the system moves from state 3 to 4. So we say that the heat transferred from state 3 to 4 is equals to, you can see on the table, negative 2,250 kilojoule per minute, right? So there's heat rejected from the system. That's why the negative is there. And the work transferred or the work done from state 3 to 4 is unknown. And the internal energy from state 3 to 4 is giving us negative 38,800 kilojoule per minute. Now, if I substitute this into equation 1, I am going to be having my dq, which is giving us q3 to 4, and that is negative 2250, equals to the u3 to 4, and that's giving us minus 38,800 plus the work done, which is w3 to 4, and that is unknown. So we'll now say that collect like terms minus 2,250. If the negative 38,800 comes to the left hand side, become positive, so we have plus 38,800 equals to W3 to 4. That is the work done from state 3 to what? To 4. Now, this will now give us 36,550 kilojoule per minute. Now, recall, we know that the summation of the heat input in the system is equals to the heat from state 1 to 2 plus the heat from state 2 to 3 plus the heat from state 3 to 4 plus the heat from state 4 to 1. That is the heat from process 1 to 2, process 2 to 3, process 3 to 4, and process 4 to 1. That is what the summation means, addition. So if I say summation of boys in the class means the total boys in the class. So if I say summation of the heat in the heat here means you add all the heat together. So remember, it's a cycle. You start to move forward. You start from 1, you end at 1. That's why you see the subscript of Q have 1 to 2, and the last one is 4 to 1. So we're moving in a cycle. Now, one thing you need to understand here is this. You see, the internal energy is a stored energy, and the heat and work are what? Transitional energy. You have to have that. Take that. So now, if you start from the question, we are told that the sum of all the heat transferred during the cycle is negative 220 kilojoule. So the sum of all the heat is what? Minus 220, right? For how many cycle? 120 cycle. That is system complete 120 cycle. So you multiply it by 120, right? Equals to Q12 is 0 plus Q23, Q2 to 3 is 22,500 minus 2,250 plus Q4 to 1, right? These are what we have here. If you input your values into that equation 2 we have here. Now, if you do that, if you multiply negative 220 times 120, we have in negative 26,400 equals to, if you add 0 plus 22,500 minus 2,250, you are going to be having 20,250 plus the Q4 to 1. Now, if I take the 20,250 to the left-hand side, it will become negative. So I'll be having negative 26,400, negative 20,250 equals to Q4 to 1. Now, when you do the needful, we'll be having minus 46,650 kilojoule per minute. That is our what? The heat transferred from state 4 to 1. That is process 4 to 1. So it is a what? This is an heat rejected. Is that taken? Now also recall. So put in the table here, add that 4 to 1, so that we'll place there 46,000, negative 40,650. Now recall, the summation of the total internal energy in the system is equals to 0. So we're completing the cycle here. So we say that the summation of the internal energy, du, is equals to the internal energy from process 1 to 2 plus internal energy from process 2 to 3 plus internal energy from process 3 to 4 plus the internal energy from process 4 to 1, right? So we know that we have given it that the internal energy here is what? Is 0. So I write my 0 here, equals to U1 to 2 is giving us 3,000 minus 3,120 plus U2 to 3 is giving us 22,500. U3 to 4 is minus 38,800 plus U4 to 1. So if you do the needful, we're having 0 equals to, when you do the summation of everything you have here, minus 3,120 plus 22,500 minus 38,800 will give us minus 19,420 plus U4 to 1. Now, if I take the negative 19,420 to the left-hand side of the equal sign, I'll be having my U4 to 1 to be equals to 19,420 kilojoule per minute. Is that taken now? So that's what we have at this particular point here. Is that taken? So from here, recall that my dq is equal to du plus dw. That's my equation 1 you can see on the screen. So what is the q that we calculated for? The q here, the total heat, is giving us minus 46,650 equals to the summation of the u we have here is giving us 19,420 plus the summation of the w we don't have yet. So I'll just write it what? I'll just write it W4 to 1 here. Is that taken? Now, if I should do that, If I should take the 19,420 to the left hand side of the equal sign, it will become negative. So this will now give me minus 46,650 minus 19,420 equals to W4 to 1, right? So when we do this, what we're going to be having when you add these two negative values together, you'll be having negative 66,070 kilojoule per minute. That will be the work from state 4, the work done from state 4 to what? To 1, right? Is that okay? So now we've gotten that. So we'll now look for the net work output. So I'll say recall the summation of W will now give us W12 plus W2 to 3 plus W3 to 4 plus W4 to 1. Is that okay? So from here, we will now be having my summation of the W will now give me 3,120 plus 0 plus 36,550 minus 66,070. So if you do the needful, we are going to be having this to give us we're having to give us minus 26,400. Is that taken? So that is my value I have here, minus 26,400. So if you have gotten that, so the net ratio of work output, it won't convert it from minute to second, kilojoule per minute to kilojoule per seconds, right? So that will be 26 minus 26,400 divided by 60, because 60 minutes, 60 seconds make 1 minute. So per minute means 1 minute. So we'll now have minus 44, minus 440 kilojoule per seconds. Now we know joule per second is the same as in watts. So we'll now have this to be minus 440 kilowatts. Is that taken? So this is what we have. So we have successfully analyzed this problem. So if you have found it helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.